Okay, we took this in class, but for absent people or those who may need a review, period and frequency, we've been talking about period, and frequency is something very closely related to it. It's easy to get the two kind of flipped around, so this is a good way to just kind of key the helpful hints to keep them separate, okay? So most of this should be a review. Period is the time it takes for one cycle, and you measure that in seconds. This is just like what we did in the lab. You calculate period if you have cycles and the time it takes by dividing the number of, by taking that time and dividing by the number of cycles, okay? So it's time on top, cycles on the bottom. So this statement here, I could give this to you and ask you either what is the period or what is the frequency. And how you do it is dependent on remembering these rules. So a pendulum swings 8 times in 40 seconds. Should you divide 8 by 40 or 40 by 8? So based on time always being on top, it should be 40 seconds divided by our 8 cycles, which gives us 5 seconds. Okay? So you try this one. Pendulum swings 30 times in 60 seconds. What is the period? Hopefully you did 60 divided by 30 and got 2 seconds, okay? So frequency, this is the new thing that we haven't really talked about yet, though you have seen this in that book review. So frequency is the number of cycles per second. So how many cycles happen in 1 second, or how much of one cycle happens in a second? You know, if the period takes 6 seconds, obviously the whole cycle doesn't happen in 1 second, okay? But number of cycles per second, and this is measured in hertz, which you can abbreviate as capital H, lowercase z. And what that actually means is just 1 over seconds, okay? And that's because we need to know what it is per second, cycles per second. So your units have to be per seconds. So to calculate frequency, it's the exact opposite of period. You calculate by taking the number of cycles and divide by the time. So cycles over time. So you'll notice this looks familiar. We have a pendulum swinging 8 times in 40 seconds. This time, do you divide 8 by 40 or 40 by 8? So it's frequency. We do the opposite of what we did with period. We want our cycles on top, or our swings, and our time on the bottom. So 8 divided by 40, if you plug that in the calculator, you get 0.2 hertz. Okay? So once again, try it on your own. And hopefully this time you did 30 divided by 60 and got 0.5 hertz. Okay? So last thing I want to cover, and this is what came out of the book, is an equation that relates the two of these together. Specifically for problems like this, where I don't tell you the cycles and I don't tell you the time that they take, I just give you the pendulum period, or I just give you the frequency and then ask for the other one. So frequency and period are inversely related. So if you think about math class and your inverse relationship rules, one is equal to the same thing, but 1 divided by it, okay? Kind of think about it this way. When we were calculating our numbers before, we were getting 5 seconds and 0.2 hertz. And then we were getting 2 seconds and 0.5 hertz, okay? So what's happening here is that one has to be greater than 1, the other one has to be less than 1. And that's another way of thinking of an inverse relationship. So which of these two equations is going to be helpful for our current problem? The period of the pendulum is 0.2 seconds. Right? Our known is period. Our question is frequency. So we want the equation that solves for frequency and has period in the equation, because that's what we know. All right? So you do 1 over 0.2 seconds, and that would give you 5 1/2 or hertz. So no assignment to do with this one, just the problems on the half sheet. The first 8 or so are related to this concept. So if you're having issues with them, watch this and hopefully it helps.